Ever wondered how your source code gets converted into an executable file? It's a fascinating journey that goes through several distinct stages. Buckle up, because we're about to embark on this captivating exploration. The first stage is pre-processing. Picture a preprocessor program like the C preprocessor, scanning the source code file and performing a series of tasks. Think of expanding macros, where the preprocessor replaces macro invocations with their respective definitions. Then there's the inclusion of header files, where the preprocessor integrates the contents of these files into the source code file. Lastly, conditional compilation takes place, where the preprocessor evaluates conditional directives and decides whether to include or exclude parts of the code based on their evaluation. The result? Preprocessed code, an intermediate form of the initial source code. Next up, we have compilation. This is where things get interesting. Here, the preprocessed code gets translated into assembly language, specifically tailored to the target architecture. The compiler doesn't just translate, it analyzes the code, performs syntax and semantic checks, and generates the corresponding assembly code. This is a low-level representation of the source code, using mnemonics and symbols that are unique to the target architecture. Then we move to the assembly stage. This is where the assembly code gets converted into binary machine code. An assembler program like NASM or GAS reads the assembly code and produces an object file. This file contains the machine code instructions, along with additional metadata. Each instruction in the assembly code corresponds to a specific machine code instruction of the target architecture. And finally, we reach the linking stage. This is the grand finale where everything comes together. Multiple object files are combined, references between them are resolved, and a single executable or library file is produced. The linker program, like LD, performs this process. It resolves symbols, which are variables and functions defined in one object file but referenced in another. The linker might also link necessary libraries and perform other tasks like relocations and optimizations. At the end of this journey, we have an executable file or a library file that can be loaded and executed by the operating system or used as a dependency by other programs. Remember, the specifics of these stages can vary depending on the programming language, compiler, and target platform. But the general concepts and flow stay mainly the same across most compiled languages. So the next time you execute a program, take a moment to appreciate the intricate journey it has been through, from being a source code to becoming an executable file. That's the magic of programming, and it's happening right under your fingertips.